Hi everyone. In this video I explain what a dynamic array is and how it works. I first go over the concept and then I explain how it works in code in C++. Let's start out with the concept. Essentially, a dynamic array is just a plain old array that you already know, but there's some code around it that manages the resizing of that array when that array gets full. In this example, I have an integer pointer named array and I initialize it to a new array of size 5. I just picked 5 as an example. It could really be any size initially that you feel you need in your programs to store the elements. You don't want to make it too large, because if you make it too large and you don't end up using that memory space, you just waste a lot of space that you don't need. Typically, by default, most of the time it's 10, but I keep it to 5 to keep that example short. Now initially this array is empty, and then in my program I add the first element, which is the value of 1. It is stored at index 0. Then I add another element which is 5, and that gets stored at index 1. And you can assume you use this array in your code. Whenever you want to add elements, you might update elements, you might prompt the user to add a value, and you store that in the array. So it's not just sequentially keep adding elements, but just use that array in your program. As you add on elements, in this example here I add 8, then I add 2, and finally I add 7. And now eventually this array is full. As we know, there's no way to increase the size of an array in C++. Arrays are fixed size. But what I want to do with the dynamic array is double the size of this array. So let's see how this works. I take the size of this array, which is 5. I multiply 5 by 2, so I get 10. And now I want to create a new array of size 10. I have a new integer pointer named newArray. I initialize it to a new integer array of size 10. So I have now the old array that is full, that holds all the elements. And I have the new array that is empty, but it has twice the capacity, so it can store up to 10 elements. As a next step, I copy the elements from the old array to the new array. I use a for loop that starts at index 0 up until the size. So remember, size is 5. And it loops through the old array and assigns an element from the old array to the new array. So after that for loop, the new array has all the elements that were stored in the old array, and it has space for 5 additional elements that I could store in the future. Now the next step is I want to delete my old array. I use the delete command to free up that memory, and now the pointer is currently invalid because I deleted this array. But I still have the pointer that points to the new array. So next, I update the pointer, so the array pointer points to the address of the new array. And essentially what this means is that the array points now to the new array that can store 5 additional elements. Now as I use the pointer named array in my code is not even aware that the array behind it changed. It just knows I have a pointer named array. I can access it with the bracket syntax. I can assign elements, I can update elements. When this is full, my code runs, updates the actual array behind the pointer that the pointer points to, and then I can keep using this array. Now if this were to get full again, the same code runs again. Obviously we don't want to mix this code into the application. So typically there's a class around it that manages it. You might be familiar with the vector class in C++, and this is essentially what it does behind the scenes. So let's take a look at the code. Now here is a summary of the code that I just used in the concept. I initially have a capacity of 3. I have an integer pointer named array. I initialize it to a new array with a capacity of 3. Then I run any kind of code. This could be a lot longer, but for a short example to give you then an idea, I just assign 3 elements, 8, 3, and 5. Now this array is full, so I take the size, which is the capacity, so capacity here is 3. I store 3, then I double the capacity, so capacity would now be 6. I create a new array, initialize it to a new integer array with a new capacity of 6. Then I take a loop up until the size, so this is still 3. I copy all the elements from the old array to the new array. So my new array now has the same elements, but it has additional capacity of 3. So it is just half full at this time. I no longer need the old array, so I delete that and free up that memory. And then I update the pointer of the original array and point to the array of the new array. So this now has an array of size 6. It stores the value 8, 3, and 5, and has space for additional 3 elements. This is just a summary how it works to make it really straightforward, but let's see how this works in a class. Here I created a class named Dynamic Array. I use a template named T, so this can be used for any type. The data is essentially the pointer that points to an array. I have a size field, I have a capacity field, and I have a constructor. Now the constructor's initial capacity is 4, but I could also, whenever I need a dynamic array, say, I don't want the default size, I may want a size of 10 or 20 or 100 initially. But if nothing is provided, the initial capacity is 4. I also initialize the size to 0 because the size represents the number of elements stored in the array. And I initialize the capacity to the initial capacity. So capacity is a space or number of elements that I can potentially hold until the array is full. Size is the actual elements that I currently store in the array. I also have a check here. If the initial capacity is less than or equal 0, this is invalid. The initial capacity has to be at least 1. And if everything is good, then I take my data, which is the pointer, and initialize it to a new array of the original capacity. So again, if the default value is taken, this would be now an array of size 4. I have the destructor that deletes the array if it's no longer needed. And then I have the add method. So the add method takes in a new value. It first checks if the array is full, and this is by checking if the size matches the capacity. Again, the size is the number of elements, and the capacity is essentially the size of the array or the number of elements that can be stored in the array. So if the size matches capacity, I know the array is full. Initially, this will not be the case. So I take the value and store it at size, index size, and then increment size by 1. So size, if you look up here, is initially 0. So the first element would be stored at index 0. If I call this again, it would be stored at index 1. Size is incremented to 2. And so every time I want to check the size, now the size is 2. I have 2 elements in it. If I call add again, I store it at index 2. I increment the size to 3. And if I call it a 4th time, I store the 4th value at index size. I increment size from 3 to 4. And now when I call it a 5th time, I see the capacity is full. 4 is the size, 4 is also the capacity. And here I have a private function named size. So let's see what happens here. I take the current capacity, multiply it by 2. So this gives me double the size that I want. I create a new array named new data, initialize it to a new array of the new capacity. So here for the default value, it would be 8 because originally I had 4. Multiplied 4 by 2 is 8, and I have a new array of 8. Then I use a for loop, copy the elements from the old array to the new array. Then I delete the original array that I had and update the pointer. So that data now points to the new array. Now with all this, this is pretty much it. This is how a dynamic array works. So let's see how it works when I use this dynamic array. I have a main function. Here I say I want to have a dynamic array of integers, and I call this int array. Then I add elements 10, 20, 30, 40, and 50. Now I didn't specify the size here, so I took the default capacity originally. It was 4 elements. So adding 10 is fine, adding 20 is fine, adding 30 is fine, adding 40 is fine. Now I have 4 elements in my array, and this array is full. So here, when I call add 50, this will trigger a resize. Let's see how this works. I need to rename my main here. I put a breakpoint right here when this is full. I click play. And now it stops here at the breakpoint. So let's go into the function. So size is currently 4. Capacity is also 4. So this one is true. I go to the next line. The condition was 2, and now it calls resize. Capacity is 4. It multiplies it by 2. So capacity is now 8. If I expand this down here, we can see it's 8. It creates a new array. It uses a for loop to go through the old array, 1, 2, 3, 4. Then it's done. It deletes now the old array and assigns the new array to the old array. Now I go up here, resize was called. I now have an array of twice the size. I can assign the value to the next position. You can see down here, this might be a bit small, but the new size or the new capacity is 8. The size is 4. And if I go over this, size is now 5. I have 5 elements. I still have space for 3 additional elements. And when I go out here and I call the print function, I can see my array holds values 10, 20, 30, 40, and 50. Now I have another example with a string array. So I create a dynamic array that holds strings called string array. And I add the values hello, world, dynamic, and array. And then when I call print, it prints out these values. Now, had I called add an additional time, it would have increased the dynamic array to twice the size and add that additional element. So what you see here on the main code is I can keep on adding elements. It uses an array underneath the hood, but I really don't notice that it does the resizing and creating new arrays and updating the pointers. So from the program perspective, I can treat it as a black box where I can keep on adding and adding and adding additional elements as I need that in my program. Yet at the same time, I don't waste any space if I don't need all those elements. So dynamic arrays always double in sizes. If I start with 4, if it gets full, it would have a capacity of 8. If that gets full, it would have a capacity of 16, then 32, then 64, and so on. The reason is that the copy operation to copy the elements from the existing array to the new array is expensive. So we want to minimize that copy operation. And by just increasing it by 4, if we know we reached the limit a few times already, there's a likelihood we need more than 4 elements as we increase that array. So by doubling the capacity of what we originally have, it's a compromise of not having too much memory allocated, but yet at the same time to be prepared to have sufficient space for future elements that we need. Another question you may have is, do we ever shrink a dynamic array? Dynamic array is never decreased in size. Even if we keep deleting elements, it always preserves the capacity that it reached at some point. The reason behind that is that if you needed that capacity at some point in your program, there's a very good chance that you need the same capacity at a later point in your program. I hope you enjoyed this video. Thank you for watching.